Question 1. Implementation of temporary role-based access to a critical production server for a specific team of engineers for a 48-hour period to perform essential maintenance, without granting them permanent elevated privileges or requiring manual intervention for access revocation, is best achieved by which method within Cisco Identity Services Engine? Option A. Create a new, permanent security group in Cisco ISE for the engineers and assign them to it, assuming they will be removed from the group manually after the maintenance is complete. Option B. Configure a time-bound authorization policy in Cisco ISE that grants access to the critical server based on membership in a newly created temporary security group, with an automatic expiration set for 48 hours. Option C. Grant the engineers full administrative privileges to the entire network infrastructure for the 48-hour maintenance window. Option D. Manually create a static access control list, ACL, entry on the critical server allowing access from the engineer's IP addresses for 48 hours, with a reminder to manually remove the ACL entry afterward. The correct answer is B. Configure a time-bound authorization policy in Cisco ISE that grants access to the critical server based on membership in a newly created temporary security group, with an automatic expiration set for 48 hours. Explanation. Scenario analysis. This scenario presents a common challenge in network security, balancing the need for granular access control with the operational overhead of managing numerous policies. The professional challenge lies in identifying the most efficient and secure method to grant temporary, role-based access to a critical server for a specific group of users, without compromising the overall security posture or creating long-term vulnerabilities. The potential for misconfiguration or overly broad permissions necessitates a careful and informed decision. Correct approach analysis. The correct approach leverages the capabilities of Cisco Identity Services Engine, ISE, to dynamically assign access based on user identity and group membership, combined with a time-bound authorization rule. This aligns with the principle of least privilege, ensuring users only have access when and to what they need. By defining a specific group for the temporary access and creating a time-limited authorization policy within ISE, the system automatically revokes access once the defined period expires. This is a best professional practice because it is automated, auditable, and minimizes the risk of human error in manual access removal. It directly supports the security objectives of controlled access and timely revocation, which are fundamental to robust network security and compliance. Incorrect approaches analysis. Manually creating a permanent access control list, ACL entry for the specific server, and then remembering to remove it later is a significant regulatory and ethical failure. This approach introduces a high risk of human error, leading to persistent, unauthorized access after the temporary need has passed. This violates the principle of least privilege and creates a security vulnerability that could be exploited. Furthermore, it bypasses the centralized policy management and auditing capabilities of ISE, making it difficult to track who had access and when, which is crucial for compliance and incident response. Granting administrative privileges to the entire network for the duration of the task is a severe security and ethical lapse. This is a gross violation of the principle of least privilege, exposing the entire network to potential compromise. Such broad access is never justifiable for a specific server task and would likely violate numerous security policies and regulatory requirements related to data protection and access control. Creating a new, permanent security group in ISE for this temporary access and assigning users to it without a clear plan for removal is also problematic. While it uses ISE, it fails to address the temporary nature of the requirement. This leads to policy bloat and the accumulation of unused or outdated access rights, increasing the attack surface and complicating future policy management. It also creates a situation where access might persist longer than intended, similar to the manual ACL issue, albeit managed within ISE. Professional reasoning. Professionals should approach such scenarios by first understanding the exact scope and duration of the required access. They should then consult the capabilities of their security tools, such as Cisco ISE, to determine the most secure and efficient method for implementing temporary, role-based access. The decision-making process should prioritize automation, adherence to the principle of least privilege, and the ability to audit access. When in doubt, consulting security best practices documentation and internal security policies is crucial. The goal is always to implement controls that are effective, manageable, and compliant with relevant regulations. Question 2. Risk assessment procedures indicate that users are experiencing intermittent failures when attempting to connect to the corporate wireless network, with some devices being denied access by Cisco Identity Services Engine (ISE). The network administrators have observed that these failures do not correlate with any specific time of day or user group, suggesting a non-obvious cause. The organization operates under strict data privacy regulations that mandate robust access control and auditing. Which of the following approaches is the most appropriate for diagnosing and resolving these intermittent access failures while adhering to regulatory compliance? Option A. Immediately disable the ISE posture assessment service for all endpoints to reduce the load on ISE and allow all devices to connect. Then investigate the posture issues later. Option B. Focus troubleshooting efforts exclusively on the wireless access points and network switches, assuming the ISE configuration is correct and the issue lies solely with the network edge devices. Option C. Systematically review Cisco ISE logs, including authentication and authorization logs, posture assessment results, and system events, correlating these with network access device logs and recent ISE policy changes to identify patterns or specific error messages. Option D. Roll back all recent configuration changes made to the network infrastructure, including switches, wireless controllers, and ISE, to a known stable state without detailed analysis of each change. The correct answer is C. Systematically review Cisco ISE logs, including authentication and authorization logs, posture assessment results, and system events, correlating these with network access device logs and recent ISE policy changes to identify patterns or specific error messages. Explanation. Scenario analysis. This scenario presents a common challenge in network security where a critical security service, Network Access Control (NAC), via Cisco ISE, is experiencing intermittent failures. The professional challenge lies in diagnosing and resolving these failures without causing further disruption to network operations or compromising security posture. The intermittent nature of the issue adds complexity, making it difficult to replicate and isolate the root cause. The need to maintain compliance with security policies and ensure the integrity of access control decisions adds further pressure. Correct approach analysis. The correct approach involves a systematic and data-driven investigation, leveraging the diagnostic tools and logging capabilities inherent in Cisco ISE. This aligns with best practices for incident response and troubleshooting in regulated environments. Specifically, examining ISE logs for authentication and authorization events, correlating these with network device logs, e.g., WLC switches, and reviewing ISE policy configurations for any recent changes or potential misconfigurations are crucial. This methodical approach ensures that the resolution is based on evidence, minimizes the risk of introducing new vulnerabilities, and allows for proper documentation for audit and compliance purposes. Adhering to the principle of least privilege and ensuring that troubleshooting steps do not inadvertently grant unauthorized access are paramount. Incorrect approaches analysis. One incorrect approach is to immediately revert all recent configuration changes without proper analysis. This is a blunt instrument that could undo necessary security updates or functional improvements, and it fails to identify the specific cause of the problem, leaving the underlying vulnerability unaddressed. This approach risks introducing security gaps or operational instability by reverting functional configurations. Another incorrect approach is to disable security policies or features within ISE to restore connectivity temporarily. This directly violates the security objectives of NAC and exposes the network to unauthorized access, creating significant regulatory and ethical failures. It prioritizes availability over security, which is unacceptable in a compliance-driven environment. A third incorrect approach is to focus solely on external network infrastructure without examining ISE's internal state and logs. While external factors can contribute, ISE is the central decision-making point for NAC. Ignoring its logs and configuration means missing critical information about why it might be denying or failing to authenticate endpoints, leading to an incomplete and ineffective troubleshooting process. This failure to investigate the core component of the NAC solution is a significant professional lapse. Professional reasoning. Professionals should approach such issues by first establishing a clear understanding of the problem's scope and impact. This involves gathering information from affected users and systems. Next, a systematic troubleshooting methodology should be employed, starting with the most likely causes and progressively investigating deeper. This includes reviewing logs, configuration, and system health. Any changes made during troubleshooting should be documented meticulously, and where possible, tested in a non-production environment or with minimal impact. The decision-making process should always prioritize maintaining the security posture and compliance requirements, even when faced with operational challenges. Escalation to vendor support or subject matter experts should be considered when internal expertise is insufficient. Question 3. The efficiency study reveals that the onboarding process for new contractors is taking an unacceptably long time, impacting project timelines. The network access provisioning relies heavily on Cisco Identity Services Engine (SISE) for dynamic policy enforcement and endpoint profiling. The current configuration appears to be causing delays in granting initial network access to these contractors. What is the most effective approach to address this delay while maintaining robust security? Option A. Disable endpoint profiling on ISE for all contractor devices to remove any potential classification delays. Option B. Implement a manual approval workflow for every contractor's network access request to ensure individual scrutiny. Option C. Review and optimize the endpoint profiling policies and authorization rules within ISE to ensure efficient and accurate classification of contractor devices and roles, thereby streamlining the access granting process. Option D. Grant all new contractors full administrative privileges upon initial network connection to expedite their access and minimize delays. The correct answer is C. Review and optimize the endpoint profiling policies and authorization rules within ISE to ensure efficient and accurate classification of contractor devices and roles, thereby streamlining the access granting process. Explanation. The efficiency study reveals a significant bottleneck in the network access provisioning process, leading to delays in onboarding new employees and contractors. This scenario is professionally challenging because it directly impacts business operations and user productivity. The Cisco Identity Services Engine, SISE, plays a crucial role in automating and enforcing access policies, and any inefficiencies in its configuration or operation can have widespread consequences. Careful judgment is required to identify the root cause of the delay and implement a solution that is both effective and compliant with security best practices and any relevant organizational policies. The correct approach involves a systematic review of the ISE policy configuration related to endpoint profiling and authorization policies for new users. Specifically, examining the conditions and rules that determine the initial access level and the subsequent profiling steps is paramount. Ensuring that profiling policies are granular enough to accurately identify device types and user roles, while also being efficient in their execution, is key. This approach represents best professional practice because it directly addresses the identified inefficiency by optimizing the core functionality of ISE responsible for dynamic access control. It aligns with the principle of least privilege by ensuring users and devices are granted only the necessary access based on their identity and context, thereby enhancing security posture while improving operational efficiency. This proactive and analytical method is crucial for maintaining a secure and functional network environment. An incorrect approach would be to broadly increase access privileges for all new users to bypass the profiling process. This is a regulatory and ethical failure because it directly violates the principle of least privilege, a fundamental security tenet. It exposes the network to significant risks by granting potentially unauthorized access to sensitive resources, increasing the vulnerability to malware propagation and data breaches. Another incorrect approach would be to disable endpoint profiling altogether. This is a failure to adhere to security best practices and potentially organizational policies that mandate proper device identification and classification for security and compliance reasons. It removes a critical layer of visibility and control, making it impossible to enforce granular access policies based on device posture or type. A third incorrect approach would be to manually approve every new user's access request. While seemingly a direct solution to the delay, this is a failure in implementing automated security controls, which is a primary purpose of ISC. It is not scalable, prone to human error, and negates the efficiency gains ISC is designed to provide, ultimately leading to further operational bottlenecks and increased risk. Professionals should approach such situations by first thoroughly understanding the reported problem and its impact. They should then leverage their knowledge of the Cisco ISE architecture and its policy enforcement mechanisms to hypothesize potential causes. A structured troubleshooting methodology involving reviewing logs, policy configurations, and network flows is essential. When considering solutions, professionals must always balance efficiency with security and compliance requirements. This involves evaluating proposed changes against established security principles, organizational policies, and any relevant industry standards or regulations. The decision-making process should prioritize solutions that enhance both security and operational efficiency, rather than sacrificing one for the other. Question 4. System analysis indicates that a newly deployed business-critical application requires access to specific databases and internal services hosted on different network segments. The application server is currently unmanaged by Cisco Identity Services Engine (ISE) and has no defined network access policies. To ensure business continuity, a quick solution is needed, but security and compliance must be maintained. What is the most appropriate course of action to grant the application the necessary network access while adhering to security best practices and potential regulatory requirements? Option A. Assign the application server to the same network segment as the databases and internal services and grant it full network access within that segment. Option B. Temporarily disable all existing security policies on the network segment where the application server resides until a comprehensive security assessment can be completed. Option C. Configure Cisco ISE to create a specific network access policy that grants the application server access only to the required database servers and internal services, using specific ports and protocols, and enforce this policy based on the application server's identity. Option D. Implement a broad firewall rule to allow all inbound and outbound traffic for the application server's IP address to any destination on the network. The correct answer is C. Configure Cisco ISE to create a specific network access policy that grants the application server access only to the required database servers and internal services, using specific ports and protocols, and enforce this policy based on the application server's identity. Explanation. Scenario analysis. This scenario presents a common challenge in network security where a new application requires specific network access, potentially conflicting with existing security policies. The professional must balance the business need for the application's functionality with the imperative to maintain a secure network posture. The challenge lies in understanding the implications of granting broad access versus implementing granular controls, all while adhering to the principles of least privilege and regulatory compliance. The pressure to enable business operations quickly can lead to rushed decisions that compromise security. Correct approach analysis. The correct approach involves a thorough risk assessment and the implementation of granular access controls. This aligns with the principle of least privilege, a cornerstone of modern cybersecurity, and a requirement implicitly or explicitly found in many regulatory frameworks governing data protection and network security. By identifying the specific network resources the application needs and the exact ports and protocols required, administrators can configure Cisco ISE to grant only the necessary access. This minimizes the attack surface and reduces the potential impact of a compromise. Furthermore, this approach allows for detailed logging and auditing, which are crucial for compliance with regulations that mandate accountability and incident response capabilities. Incorrect approaches analysis. Granting broad network access to the entire subnet where the application resides is a significant security failure. This violates the principle of least privilege by providing access to resources the application does not require, thereby increasing the attack surface. From a regulatory perspective, this could lead to non-compliance with data protection laws that require organizations to implement appropriate technical and organizational measures to protect personal data. If a breach occurs, the organization could face penalties for insufficient security controls. Implementing a blanket firewall rule to allow all traffic from the application server to any destination is equally problematic. This is an extreme violation of the principle of least privilege and creates a wide-open pathway for potential malicious activity. It negates the purpose of a segmented and controlled network. Regulatory frameworks often mandate that network access be restricted only what is necessary for legitimate business functions. Such an approach would likely be flagged during an audit as a severe security deficiency. Disabling security policies for the application server until a full assessment can be completed is a reactive and dangerous approach. While seemingly a temporary measure to enable business, it leaves the server and potentially the entire network vulnerable. This is a direct contravention of the proactive security posture expected by most regulatory bodies. It demonstrates a failure to prioritize security and could result in immediate compromise and subsequent regulatory penalties. Professional reasoning. Professionals should adopt a systematic approach to access control requests. This involves 1. Understanding the business need. Clearly define what the application needs to do and why. 2. Threat modeling. Assess the potential risks associated with granting the requested access. 3. Policy definition. Determine the minimum necessary access required, adhering to the principle of least privilege. 4. Implementation. Configure Cisco ISE with specific policies, profiles, and access rules. 5. Verification and monitoring. Test the implemented policies to ensure they function as intended and continuously monitor for anomalies. 6. Documentation. Maintain detailed records of all access control decisions and configurations for auditing and compliance purposes. Question 5. Investigation of intermittent user authentication failures and authorization policy discrepancies within a Cisco Identity Services Engine ISE deployment, where administrators suspect a configuration issue but are unsure of the specific component responsible. Option A. Immediately revert all recent changes to authentication policies and restart all ISE services across all nodes to restore functionality. Option B. Systematically review ISE node health, network connectivity to critical infrastructure, and core ISE service status, followed by detailed analysis of ISE logs for error messages correlating with the reported failures. Option C. Initiate a full system backup of ISE and then proceed with randomly disabling and re-enabling various ISE services to observe any changes in behavior. Option D. Focus troubleshooting efforts exclusively on external firewall rules and network access control lists, ACL, between ISE and the Radius clients. The correct answer is B. Systematically review ISE node health, network connectivity to critical infrastructure, and core ISE service status, followed by detailed analysis of ISE logs for error messages correlating with the reported failures. Explanation. Scenario analysis. This scenario presents a common challenge in network security where a critical security service, Cisco Identity Services Engine ISE, is experiencing intermittent failures impacting user access. The challenge lies in diagnosing the root cause efficiently and accurately without further disrupting services or compromising security. The pressure to restore functionality quickly, coupled with the potential for misdiagnosis leading to incorrect remediation, makes careful judgment and a systematic approach paramount. The complexity of ISE, with its multiple integrated services, authentication, authorization, posture, profiling, etc., further complicates the troubleshooting process. Correct approach analysis. The correct approach involves a methodical, layered investigation that begins with verifying the fundamental health and connectivity of the ISE nodes and their essential services. This aligns with best practices for troubleshooting distributed systems and network security appliances. Specifically, checking the ISE node status, network connectivity to critical infrastructure Active Directory, Radius clients, DNS, NTP, and the health of core ISE services, e.g., policy service, administration monitoring, provides a baseline understanding. Examining ISE logs for specific error messages related to authentication, authorization, or policy enforcement during the reported failure times is crucial for pinpointing the exact point of failure. This systematic approach minimizes the risk of implementing ineffective or potentially harmful changes and ensures that the troubleshooting effort is focused and efficient, directly addressing the reported symptoms within the operational context of the Cisco ISE implementation. Incorrect approaches analysis. Implementing a broad, unverified change to the authentication policies without a clear understanding of the root cause is a significant regulatory and ethical failure. This approach bypasses the diagnostic process, potentially introducing new vulnerabilities or misconfigurations that could violate security policies or compliance requirements. It demonstrates a lack of due diligence and a disregard for the principle of least privilege in secure configuration management. Randomly restarting ISE services or nodes without correlating the restarts with specific error messages or known issues is also professionally unacceptable. This shotgun approach can lead to unintended consequences, such as data corruption, loss of configuration, or temporary service outages that are not directly related to the original problem. It fails to adhere to a structured troubleshooting methodology and can obscure the actual root cause, making future diagnosis more difficult. Focusing solely on external network connectivity issues, e.g., firewall rules, without first verifying the internal health and configuration of ISE itself is an incomplete troubleshooting strategy. While external connectivity is important, it is not the sole determinant of ISE functionality. This approach risks overlooking internal ISE configuration errors or service degradations that are the actual cause of the problem, leading to wasted effort and prolonged downtime. Professional reasoning. Professionals facing such a scenario should adopt a structured troubleshooting framework. This typically involves 1. Understanding the problem. Gather detailed information about the symptoms, affected users, and the timeline of events. 2. Establishing a theory of probable cause. Based on the symptoms, hypothesize potential causes starting with the most likely. 3. Testing the theory. Implement diagnostic steps to confirm or refute the hypothesized causes. This includes checking logs, system status, and network connectivity. 4. Establishing a plan of action to resolve the problem. Once the cause is identified, plan the remediation steps, considering potential impacts. 5. Implementing the solution. Execute the remediation plan carefully. 6. Verifying full system functionality. Ensure the problem is resolved and no new issues have been introduced. 7. Documenting findings, actions, and outcomes. This is crucial for future reference and continuous improvement. Question 6. What factors determine the most appropriate method for authenticating and authorizing users and devices when implementing Cisco Identity Services Engine ISE to meet regulatory compliance requirements? Option A. The default configuration settings provided by Cisco for ISE and the ease of implementing a single, universal access policy for all network segments. Option B. The organization's existing identity sources, sensitivity of the network resources being accessed, and the specific regulatory mandates applicable to the industry and data being handled. Option C. The number of available IP addresses in the network and the speed at which devices can obtain an IP address through DHCP. Option D. The primary goal of reducing the number of authentication protocols supported by the network infrastructure, regardless of security implications. Correct answer is B. The organization's existing identity sources, the sensitivity of the network resources being accessed, and the specific regulatory mandates applicable to the industry and data being handled. Explanation. Scenario analysis. This scenario presents a common challenge in network security implementation, balancing the need for granular access control with the practicalities of managing a large and dynamic user base. The professional challenge lies in ensuring that the chosen authentication and authorization methods not only meet the technical requirements of the Cisco Identity Services Engine, ISE, but also align with the organization's internal policies and any relevant regulatory compliance mandates. The complexity arises from the potential for misconfigurations to lead to security vulnerabilities, unauthorized access, or operational disruptions. Careful judgment is required to select a method that is both secure and manageable. Correct approach analysis. The correct approach involves leveraging ISE's capabilities to integrate with existing identity sources, such as Active Directory, and then defining policies based on user identity, device posture, and network context. This aligns with best practices for implementing a zero-trust security model, where trust is never assumed and verification is always required. Specifically, using ISE to enforce policies based on user group membership and device compliance status ensures that only authenticated and authorized users on compliant devices gain access to specific network resources. This approach directly supports regulatory frameworks that mandate strong authentication and access control, preventing unauthorized access and maintaining data integrity. It also allows for dynamic policy enforcement, adapting to changes in user roles or device security posture. Incorrect approach is analysis. One incorrect approach is to rely solely on MAC address authentication for all devices. This is a significant regulatory and security failure because MAC addresses are easily spoofed, providing a false sense of security. It fails to meet requirements for strong authentication and would likely violate regulations mandating user identity verification. Another incorrect approach is to implement a single, broad access policy for all users and devices, regardless of their identity or the sensitivity of the resources they are accessing. This violates the principle of least privilege, a fundamental security and regulatory requirement, and increases the attack surface by granting unnecessary access. It also fails to meet compliance mandates that often require differentiated access based on roles and responsibilities. A third incorrect approach is to bypass ISE entirely and implement access control directly on network devices without a centralized identity management system. This leads to inconsistent policy enforcement, increased administrative overhead, and a lack of visibility and auditability, all of which are critical for regulatory compliance and effective security management. Professional reasoning. Professionals should approach this by first understanding the organization's specific security policies and any applicable regulatory requirements, e.g., HIPAA, PCI DSS, GDPR, depending on the industry and jurisdiction. Next, they should assess the existing IT infrastructure, including identity sources and network devices. The Cisco ISE documentation and best practice guides should be consulted to understand its capabilities and limitations. A phased implementation approach, starting with a pilot group and gradually expanding, is recommended. Regular auditing and testing of policies are crucial to ensure ongoing compliance and security effectiveness. The decision-making process should prioritize security, compliance, and operational efficiency, ensuring that the chosen solution is robust, auditable, and maintainable. Question 7. When evaluating the implementation of Cisco Identity Services Engine ISE for network access control, which approach best aligns with the principle of least privilege and facilitates compliance with data access regulations? Option A. Grant broad network access to all authenticated users without further segmentation or policy enforcement. Option B. Dynamically assign network access and resource permissions based on user identity, device posture, and contextual information integrated with an authoritative identity source. Option C. Implement static IP-based access control lists, ACL, for all network segments, regardless of user identity. Option D. Create overly complex and rigid access policies that are difficult to manage and audit, prioritizing granular control above all else. The correct answer is B. Dynamically assign network access and resource permissions based on user identity, device posture, and contextual information, integrated with an authoritative identity source. Explanation. Scenario analysis. This scenario presents a common challenge in network security, balancing the need for granular access control with the practicalities of managing a large and dynamic user base. The professional challenge lies in selecting an identity management strategy that is both effective in enforcing security policies and compliant with potential regulatory requirements for data access and user authentication, without introducing undue complexity or operational overhead. The inherent risk is misconfiguration, leading to either overpermissive access, violating the principle of least privilege, or overly restrictive access, hindering legitimate business operations. Correct approach analysis. The correct approach involves leveraging Cisco ISE's capabilities to create dynamic access policies based on user identity, device posture, and contextual information. This aligns with best practices for modern network security, emphasizing zero-trust principles. By integrating with an authoritative identity source, like Active Directory, ISE can authenticate users and assign them to specific security groups. These groups then drive policy enforcement, ensuring that users only have access to the resources and network segments appropriate for their role and the security posture of their device. This granular control is crucial for regulatory compliance, as it allows organizations to demonstrate that access to sensitive data is restricted to authorized personnel. Furthermore, the ability to dynamically adjust policies based on real-time context, e.g., device compliance, location, enhances security posture and reduces the attack surface. This approach is professionally sound because it is proactive, adaptable, and directly supports the principle of least privilege, a cornerstone of robust security frameworks and often a requirement in various compliance standards. Incorrect approaches analysis. One incorrect approach is to rely solely on static IP-based access control lists, ACL, without considering user identity. This fails to meet the dynamic nature of modern networks and user mobility. It is professionally unacceptable because it cannot enforce role-based access or adapt to changes in user roles or device status, leading to potential security gaps and noncompliance with regulations that mandate identity verification for access. Another incorrect approach is to grant broad network access to all authenticated users without further segmentation or policy enforcement. This violates the principle of least privilege and creates significant security risks, making it impossible to demonstrate compliance with data protection regulations that require strict access controls. It is professionally negligent as it prioritizes ease of deployment over security effectiveness. A third incorrect approach is to implement overly complex and rigid policies that are difficult to manage and audit. While granular control is important, excessive complexity can lead to misconfigurations, unintended access, and hinder troubleshooting, ultimately undermining security and compliance efforts. This approach is professionally inefficient and prone to errors. Professional reasoning. Professionals should approach this scenario by first understanding the organization's security requirements and any relevant regulatory obligations. This involves identifying sensitive data, critical systems, and the different user roles that interact with them. The next step is to evaluate the capabilities of the chosen identity management solution, such as Cisco ISE, support these requirements. The decision-making process should prioritize solutions that offer dynamic policy enforcement, integration with existing identity sources, and robust auditing capabilities. A phased implementation approach, starting with critical segments and user groups, allows for testing and refinement. Continuous monitoring and regular policy reviews are essential to maintain security posture and ensure ongoing compliance. The goal is to achieve a balance between robust security, operational efficiency, and regulatory adherence. Question 8. Cost-benefit analysis shows that implementing Cisco Identity Services Engine ISE offers significant security and compliance advantages, but the initial investment and complexity require careful planning. Given the organization's commitment to meeting stringent data privacy regulations and protecting sensitive customer information, which implementation strategy best balances these requirements with operational feasibility? Option A. Focus solely on the technical configuration of ISE for basic network access control, deferring advanced policy enforcement and compliance reporting features until after the initial deployment is stable. Option B. Deploy ISE in a phased manner, prioritizing critical network segments and user groups with access to the most sensitive data, while concurrently developing comprehensive training for IT staff and end users. Option C. Implement ISE across the entire network simultaneously to achieve immediate, comprehensive security coverage, accepting a higher initial risk of configuration errors and operational disruption. Option D. Outsource the entire ISE implementation and management to a third-party vendor without internal oversight, assuming they will fully address all regulatory compliance needs. The correct answer is B. Deploy ISE in a phased manner, prioritizing critical network segments and user groups with access to the most sensitive data, while concurrently developing comprehensive training for IT staff and end users. Explanation. The scenario presents a common challenge in network security, balancing the need for robust identity and access management with the practicalities of deployment and ongoing operational costs. 300-715 SISE exam focuses on Cisco Identity Services Engine ISE, a platform designed to enforce security policies based on user and device identity. Regulatory compliance, particularly concerning data privacy and access control, is a significant driver for implementing such solutions. The correct approach involves a phased implementation that prioritizes critical security requirements and compliance mandates. This aligns with best practices for managing complex IT projects, minimizing disruption, and ensuring that the most sensitive areas are secured first. From a regulatory perspective, this approach demonstrates due diligence in addressing identified risks and meeting obligations under frameworks like GDPR or similar data protection regulations that mandate appropriate technical and organizational measures to protect personal data. By focusing on high-risk areas first an organization can more effectively demonstrate compliance with principles of data minimization and purpose limitation, ensuring that access to sensitive information is strictly controlled. Incorrect approaches fail to adequately address the regulatory and security imperatives. Implementing a solution without a clear understanding of the regulatory landscape or without prioritizing critical assets leaves the organization vulnerable to breaches and noncompliance. This can lead to significant financial penalties, reputational damage, and loss of customer trust. A phased approach, starting with critical assets and user groups, is a sound professional decision-making process. It allows for iterative testing, refinement of policy, and better resource allocation. This methodical strategy ensures that the implementation of ISE directly supports business objectives while mitigating regulatory risks. Professionals must consider the specific regulatory requirements applicable to their industry and jurisdiction, the sensitivity of the data being protected, and the potential impact of a security incident. This holistic view informs the prioritization and configuration of ISE to achieve both security and compliance goals. Question 9. The monitoring system demonstrates that Cisco Identity Services Engine ISE is logging detailed user authentication events, including the username, IP address, authentication method, and the specific network access policy applied. However, the logs also appear to be capturing granular details about the applications accessed by users during their sessions. Which of the following configurations best aligns with regulatory compliance principles for data privacy and security? Option A. Configure ISE to log only authentication events, authorization decisions, and session start/end times, excluding any application-specific access details or user activity content. Option B. Implement logging that captures the full content of user application interactions to provide complete context for all security events. Option C. Disable all application-level logging within ISE to prevent any potential PII exposure, even if it limits security investigation capabilities. Option D. Retain all current logging settings to ensure maximum visibility for security incident response and compliance auditing. The correct answer is A. Configure ISE to log only authentication events, authorization decisions, and session start/end times, excluding any application-specific access details or user activity content. Explanation. Scenario analysis. This scenario presents a professional challenge related to maintaining regulatory compliance within a network environment managed by Cisco Identity Services Engine ISE. The core difficulty lies in balancing the need for granular network access control, as enforced by ISE, with the imperative to adhere to data privacy regulations. Specifically, the challenge is to ensure that the logging and auditing mechanisms within ISE, which are crucial for security and compliance, do not inadvertently collect or retain personally identifiable information, PI, beyond what is strictly necessary and legally permissible. This requires a nuanced understanding of both ISE's capabilities and the relevant regulatory landscape, demanding careful configuration and ongoing vigilance. Correct approach analysis. The correct approach involves configuring ISE's logging and auditing features to capture only the essential data required for security incident investigation and regulatory compliance, while actively excluding or anonymizing any PII that is not directly relevant to these purposes. This aligns with the principle of data minimization, a cornerstone of many data privacy regulations, which mandates that organizations should only collect and process personal data that is adequate, relevant, and limited to what is necessary for the purposes for which it is processed. By focusing on session details, authentication events, and authorization decisions, without logging sensitive user attributes or detailed content of network traffic, the organization upholds its commitment to privacy while still enabling effective security monitoring and auditing. This proactive stance minimizes the risk of data breaches involving PII and demonstrates a commitment to responsible data handling practices, which is often a requirement for regulatory adherence. Incorrect approaches analysis. Collecting and retaining all available log data without review or filtering is professionally unacceptable because it directly violates the principle of data minimization. This approach creates an unnecessary risk of accumulating vast amounts of PII, increasing the potential impact of a data breach, and exposing the organization to significant regulatory penalties for non-compliance with data privacy laws. Furthermore, it makes it difficult to conduct effective security investigations due to the sheer volume of irrelevant data. Disabling all logging and auditing features within ISC is also professionally unacceptable. While this might seem like a way to avoid PII collection, it fundamentally undermines the security posture of the organization. Comprehensive logging is essential for detecting security threats, investigating incidents, and demonstrating compliance with various security standards and regulations. Without adequate logs, an organization would be unable to prove its security controls are effective or to respond appropriately to security breaches, leading to potential legal and financial repercussions. Implementing logging that captures detailed user activity, including the content of communications or sensitive application usage, without a clear, documented business need and explicit consent where required, is a significant regulatory and ethical failure. This goes beyond data minimization and enters the realm of excessive surveillance, potentially violating privacy rights and specific data protection laws that govern the collection and processing of such sensitive information. It also increases the risk of misuse of collected data and can erode user trust. Professional reasoning. Professionals tasked with configuring and managing Cisco ISC must adopt a risk-based approach to logging and auditing. This involves first understanding the specific regulatory requirements applicable to their organization and jurisdiction. Then, they must identify the minimum data necessary to meet these requirements for security and compliance purposes. This necessitates a thorough review of ISC's logging capabilities, understanding what each log type captures, and configuring settings to be as restrictive as possible while still achieving the desired security outcomes. Regular audits of logging configurations and log content are crucial to ensure ongoing compliance and to adapt to evolving threats and regulatory landscapes. The decision-making process should prioritize data privacy and security by default, only enabling broader data collection when a clear, justifiable, and legally sound business requirement exists. Question 10. Operational review demonstrates that a critical business application is inaccessible to a specific user group due to an apparent misconfiguration in network access policies. The organization is subject to stringent data protection regulations that require granular control over access to sensitive customer data hosted on this application. The current Cisco Identity Services Engine ISE deployment is responsible for enforcing these access policies. What is the most appropriate and compliant approach to resolve this user access issue? Option A. Manually reconfigure firewall rules to grant temporary access to the specific IP addresses of the affected user group until the ISE issue is resolved. Option B. Temporarily disable Cisco ISE policy enforcement for the entire affected subnet until the access issue can be fully investigated and resolved. Option C. Investigate the Cisco ISE policy configuration for the affected user group and application. Identify the specific policy rule causing the denial, and implement a precise adjustment to grant the necessary access while adhering to the principle of least privilege. Option D. Implement a broad, unrestricted access policy for all users within the affected department to ensure immediate access to the application. The correct answer is C. Investigate the Cisco ISE policy configuration for the affected user group and application. Identify the specific policy rule causing the denial, and implement a precise adjustment to grant the necessary access while adhering to the principle of least privilege. Explanation. Scenario analysis. This scenario presents a common challenge in network security, balancing the need for granular access control with the operational overhead of managing complex policies. The professional challenge lies in ensuring that the implemented security posture not only meets technical requirements, but also adheres to regulatory mandates for data protection and access logging, without introducing undue complexity that could lead to misconfigurations or security gaps. The pressure to quickly resolve an access issue while maintaining compliance requires careful consideration of the underlying principles of identity and access management. Correct approach analysis. The correct approach involves leveraging Cisco ISE's policy enforcement capabilities to dynamically assign users to appropriate network segments based on their authenticated identity and context. This aligns with the principle of least privilege, a cornerstone of modern security frameworks and often a regulatory requirement. By defining policies that map user roles and device types to specific VLAN or security groups, the organization ensures that only authorized users and devices can access sensitive resources. Furthermore, ISE's logging and reporting features provide an audit trail, crucial for demonstrating compliance with regulations that mandate tracking of access to sensitive data. This approach is proactive, scalable, and inherently more secure than static configurations. Incorrect approach is analysis. Manually reconfiguring firewall rules to grant temporary access to a specific user's IP address is a procedurally flawed approach. It bypasses the centralized policy management of ISE, creating a security exception that is difficult to track and revoke. This ad hoc method increases the risk of misconfiguration, leaves a gap in the audit trail, and directly violates the principle of consistent policy enforcement, which is often a regulatory expectation for data access controls. Implementing a broad, unrestricted access policy for all users within the affected department is a significant security and regulatory failure. It violates the principle of least privilege, exposing sensitive resources to potentially unauthorized individuals. This broad access increases the attack surface and makes it impossible to demonstrate compliance with data segregation and access control requirements mandated by many data protection regulations. Disabling the ISE policy enforcement for the entire affected subnet until the issue is resolved is a critical security lapse. It removes all granular access controls and authentication mechanisms, leaving the network vulnerable to unauthorized access and potential data breaches. This action directly contravenes regulatory requirements for maintaining a secure network environment and controlling access to sensitive information. Professional reasoning. Professionals should approach such situations by first understanding the root cause of the access issue within the context of the existing ISE policy. The decision-making process should prioritize maintaining security and compliance. This involves 1. Consulting ISE logs and policies to diagnose the problem accurately. 2. If a policy gap is identified, developing a targeted policy update that addresses the specific need while adhering to least privilege. 3. Testing the updated policy in a controlled environment before deployment. 4. Ensuring that all changes are documented and logged for audit purposes. If an immediate workaround is absolutely necessary, it should be a temporary, well-documented, and tightly scoped exception, with a clear plan for its prompt removal and integration into the permanent policy. Question 11. Benchmark analysis indicates that organizations are increasingly deploying advanced network access control solutions like Cisco Identity Services Engine, ISE, to enhance security posture. However, a common challenge arises in ensuring that the data collected by ISE for policy enforcement and monitoring aligns with stringent data privacy regulations. Considering the principles of data minimization and purpose limitation, which of the following approaches best ensures regulatory compliance during the implementation and ongoing operation of Cisco ISE? Option A. Implement Cisco ISE with minimal logging and auditing, enabled to reduce the volume of personal data stored, thereby minimizing potential privacy risks. Option B. Focus solely on configuring granular access control policies based on technical attributes and user roles, without explicitly assessing the privacy implications of the data points used in these policies. Option C. Prioritize the collection of all available user and device telemetry data within ISE to facilitate comprehensive network troubleshooting and performance analysis, assuming this broad data collection is implicitly permitted for security purposes. Option D. Conduct a comprehensive data privacy impact assessment, DPIA, to identify all personal data processed by ISE, implement data minimization techniques within ISE policies, and establish clear data retention periods aligned with regulatory requirements. The correct answer is D. Conduct a comprehensive data privacy impact assessment, DPIA, to identify all personal data processed by ISE, implement data minimization techniques within ISE policies, and establish clear data retention periods aligned with regulatory requirements. Explanation. Scenario analysis. This scenario presents a professional challenge related to ensuring compliance with data privacy regulations when implementing a network access control solution like Cisco ISE. The core difficulty lies in balancing the need for granular network access policies, which often require collecting user and device information, with the strict requirements of data minimization and purpose limitation mandated by privacy laws. Organizations must avoid collecting more data than is necessary for the defined purpose of network access control, and ensure that any collected data is handled securely and only for the intended use. Failure to do so can lead to significant legal penalties, reputational damage, and loss of customer trust. Correct approach analysis. The correct approach involves a thorough data privacy impact assessment, DPIA, prior to and during the implementation of Cisco ISE. This assessment must identify all personal data that will be collected, processed, and stored by ISE, such as user credentials, device identifiers, location data, and application usage. It should then evaluate the necessity and proportionality of this data collection against the legitimate business purposes of network security and access control. Based on the DPIA findings, the organization can then implement robust data minimization techniques within ISE, such as configuring policies to collect only essential attributes for authentication and authorization, anonymizing or pseudonymizing data where feasible, and establishing strict data retention periods. This proactive, risk-based approach ensures that the implementation aligns with regulatory obligations, such as those found in GDPR, General Data Protection Regulation, or similar privacy frameworks, by embedding privacy by design and by default. Incorrect approaches analysis. Implementing Cisco ISE without conducting a DPIA and focusing solely on technical security features, without considering the privacy implications of the data collected, represents a significant regulatory failure. This approach risks overcollection of personal data, violating the principle of data minimization. It also fails to establish clear purposes for data processing, potentially leading to unauthorized secondary uses of sensitive information. Configuring ISE to collect extensive user and device telemetry for general network troubleshooting and performance monitoring, without a specific, documented, and legally justifiable purpose for each data point collected, is another regulatory failure. This broad data collection, even if intended for benign purposes, can easily exceed what is necessary for network access control and may not have explicit consent or a legitimate interest basis under privacy laws. Disabling all logging and auditing features within Cisco ISE to avoid storing any user or device activity data, while seemingly privacy protective, is an incorrect approach. This would severely hinder the ability to investigate security incidents, troubleshoot access issues, and demonstrate compliance with audit requirements, thereby failing to meet the organization's security and operational obligations. It also undermines the principle of accountability, as there would be no record of access decisions or potential policy violations. Professional reasoning. Professionals tasked with implementing Cisco ISE must adopt a privacy-centric mindset from the outset. The decision-making process should begin with understanding the applicable data privacy regulations. This involves identifying all personal data that will be processed by the system and conducting a DPIA to assess the risks to individuals' privacy. Based on this assessment, the implementation should prioritize data minimization, purpose limitation, and security by design. This means configuring ISE to collect only the data strictly necessary for its intended functions, clearly defining the purpose for each data element, and implementing appropriate security controls to protect that data. Regular reviews and updates to the DPIA and configurations are essential to maintain ongoing compliance as the network environment and regulatory landscape evolve. Question 12. Strategic planning requires a methodical approach to implementing network access control policies using Cisco Identity Services Engine (ISE) to ensure both robust security and minimal business disruption. Given the dynamic nature of device onboarding and the critical need for uninterrupted business operations, what is the most prudent strategy for deploying ISE policies? Option A. Prioritize user convenience over security by implementing minimal access controls initially, with plans to address more stringent policies only if specific security incidents occur. Option B. Deploy all available ISE features and policies without prior testing or validation in a production environment to expedite the security rollout. Option C. Implement comprehensive, restrictive access policies across the entire network immediately upon initial deployment to ensure maximum security coverage from the outset. Option D. Adopt a phased implementation strategy, beginning with critical network segments and sensitive data resources, followed by gradual expansion to other areas with continuous monitoring and policy refinement. correct answer is C. Implement comprehensive, restrictive access policies across the entire network immediately upon initial deployment to ensure maximum security coverage from the outset. Explanation. Scenario analysis. This scenario presents a common challenge in network security implementation, balancing the need for robust security controls with the operational realities of a dynamic business environment. The professional is tasked with configuring Cisco ISE to enforce access policies, but the rapid onboarding of new devices and the potential for business disruption due to strict enforcement create a tension. The challenge lies in ensuring compliance with security policies without hindering legitimate business operations, which could lead to user complaints, lost productivity, or even security vulnerabilities if users bypass controls. The need for careful judgment arises from the potential for misconfiguration to either overrestrict access, causing operational issues, or under-restrict access, creating security risks. Correct approach analysis. The correct approach involves a phased implementation strategy that prioritizes critical assets and services while allowing for a controlled rollout of comprehensive policies. This aligns with best practices for implementing security solutions in enterprise environments. By first focusing on critical infrastructure and sensitive data, the organization can ensure that its most valuable assets are protected from the outset. Subsequently, expanding policies to less critical areas in a staged manner allows for monitoring, adjustment, and user training, minimizing disruption. This approach demonstrates a proactive and risk-aware methodology, ensuring that security objectives are met without compromising business continuity. It also allows for iterative refinement of policies based on real-world observations, leading to a more effective and sustainable security posture. Incorrect approaches analysis. Implementing a set-it-and-forget-it approach with overly broad and restrictive policies from day one is a significant regulatory and ethical failure. This approach disregards the operational impact on users and business processes, potentially leading to widespread access denial for legitimate users and services. Such a failure could violate implicit service level agreements or even specific contractual obligations if the network is used for external services. It also creates a high risk of users attempting to circumvent security controls, thereby introducing new vulnerabilities. Another incorrect approach is to delay the implementation of critical security policies indefinitely due to fear of operational impact. This represents a failure to adhere to security best practices and potentially regulatory requirements for data protection and network security. By not enforcing policies, the organization remains exposed to known threats and vulnerabilities, which could lead to data breaches, financial losses, and reputational damage. This inaction is a direct contravention of the principle of due diligence in cybersecurity. Finally, implementing policies without proper testing and validation, especially in a production environment, is a critical error. This can lead to unintended consequences, such as blocking legitimate traffic or granting unauthorized access. Such a failure can result in operational downtime, security incidents, and a loss of trust in the security infrastructure. It demonstrates a lack of professional rigor and a disregard for the potential impact on the organization. Professional reasoning. Professionals should approach the implementation of Cisco ISE by first conducting a thorough risk assessment and understanding the organization's critical assets and business processes. This should be followed by a phased deployment strategy, starting with a pilot group or less critical network segments. Continuous monitoring, logging, and auditing are essential to identify and address any issues that arise during and after implementation. Regular review and refinement of policies based on operational feedback and evolving threat landscapes are also crucial for maintaining an effective and compliant security posture. This iterative and risk-based approach ensures that security controls are both effective and practical. Question 13. The assessment process reveals that while the organization has implemented a comprehensive set of security controls, there is a growing concern about the potential impact of zero-day exploits targeting critical business applications. The current risk assessment methodology primarily focuses on known vulnerabilities and compliance checklists. Which of the following approaches best addresses this emerging risk scenario within the context of a robust security program? Option A. Mandate the immediate deployment of all available security patches and updates for all systems, prioritizing those with the highest CVSS scores. Option B. Rely on the organization's security information and event management (SIEM) system to detect and alert on anomalous behavior that might indicate a zero-day exploit in progress. Option C. Increase the frequency of vulnerability scans and penetration tests to identify any exploitable weaknesses, regardless of whether they are publicly known. Option D. Enhance the risk assessment process to include threat modeling exercises that simulate potential attack vectors for critical applications, focusing on the impact and likelihood of unknown threats, and then prioritize the development of compensating controls. The correct answer is D. Enhance the risk assessment process to include threat modeling exercises that simulate potential attack vectors for critical applications, focusing on the impact and likelihood of unknown threats, and then prioritize the development of compensating controls. Explanation. The assessment process reveals a critical need to evaluate the effectiveness of existing security controls against emerging threats. This scenario is professionally challenging because it requires a proactive and strategic approach to risk management, moving beyond simple compliance to a more robust security posture. The pressure to balance security investments with operational efficiency and the dynamic nature of cyber threats necessitate careful judgment. The correct approach represents best professional practice because it directly addresses the identified gaps and prioritizes remediation based on potential impact and likelihood. This aligns with the principles of a risk-based security program, which is a cornerstone of effective cybersecurity frameworks. By focusing on the most significant risks, resources are allocated efficiently, and the organization's overall security posture is strengthened in a measurable way. This proactive stance is often implicitly or explicitly encouraged by regulatory guidelines that emphasize continuous improvement and adaptation to evolving threat landscapes. An incorrect approach that focuses solely on patching known vulnerabilities without considering the broader impact or likelihood of exploitation fails to address the root causes of risk. This can lead to a false sense of security, as critical vulnerabilities might remain unaddressed if they are not part of a widely publicized exploit. This approach can also be ethically questionable if it leads to a misallocation of resources, leaving the organization exposed to significant, albeit less publicized, threats. Another incorrect approach that prioritizes the implementation of the latest security technologies without a clear understanding of how they mitigate specific identified risks is also professionally unacceptable. This shiny object syndrome can result in wasted expenditure and complex, unmanaged systems that may introduce new vulnerabilities. It fails to demonstrate due diligence in understanding the organization's unique risk profile and the specific threats it faces. A further incorrect approach that relies solely on vendor-provided security assessments without independent validation overlooks the potential for bias and the need for an organization-specific perspective. While vendor assessments are valuable, they should be a component of a broader internal risk assessment process, not the sole determinant of security posture. This can lead to overlooking internal misconfigurations or unique business process risks that external vendors may not fully comprehend. The professional decision-making process for similar situations should involve a structured risk assessment methodology. This includes identifying assets, threats, and vulnerabilities, analyzing the likelihood and impact of potential risks, evaluating existing controls, and prioritizing remediation efforts. Professionals should continuously monitor the threat landscape, reassess risks, and adapt their security strategies accordingly. This iterative process ensures that security investments are aligned with business objectives and effectively protect the organization from the most significant threats. Question 14. The performance metrics show a sudden and significant increase in network latency across multiple critical servers, coinciding with a slight but noticeable uptick in outbound traffic to an unknown IP address. What is the most appropriate next step in assessing the potential risk? Option A. Immediately investigate the unknown IP address for known malicious activity and analyze network traffic logs for suspicious patterns related to the latency increase. Option B. Assume the latency is due to a hardware issue and schedule a hardware diagnostic for the affected servers. Option C. Increase the bandwidth allocation to the affected servers to alleviate the latency. Option D. Ignore the latency as a transient network glitch and focus on monitoring the outbound traffic for further changes. The correct answer is A. Immediately investigate the unknown IP address for known malicious activity and analyze network traffic logs for suspicious patterns related to the latency increase. Explanation: scenario analysis. This scenario presents a common challenge in network security operations, interpreting performance data to identify potential security risks. The challenge lies in distinguishing between normal operational fluctuations and indicators of a security compromise. A misinterpretation can lead to either unnecessary alarm fatigue and resource drain, or more critically, a missed security incident, exposing the organization to significant risks. The pressure to maintain network availability while ensuring security necessitates a nuanced understanding of both performance and security implications. Correct approach analysis. The correct approach involves correlating the observed performance anomalies with known security events or threat intelligence. This method aligns with best practices in security operations and incident response, emphasizing a proactive and evidence-based approach to risk assessment. By cross-referencing performance metrics with security logs, threat feeds, and established baseline behaviors, security professionals can accurately identify the root cause of the anomaly. If the anomaly is linked to a known attack vector or suspicious activity, it triggers a formal incident response process, ensuring timely mitigation and containment. This approach is ethically sound as it prioritizes the protection of organizational assets and data, adhering to the principle of due diligence in security management. It also aligns with the spirit of regulatory frameworks that mandate risk assessment and incident reporting. Incorrect approaches analysis. One incorrect approach is to immediately attribute performance degradation to hardware failure without considering security implications. This fails to acknowledge the evolving threat landscape where sophisticated attacks can manifest as performance issues. Ethically, this approach is negligent as it bypasses a crucial step in risk assessment, potentially leaving the organization vulnerable. It also violates the principle of comprehensive security analysis, which requires considering all potential causes. Another incorrect approach is to dismiss the performance metrics as insignificant noise without further investigation. This is a direct abdication of responsibility in security monitoring. It represents a failure to adhere to the fundamental requirement of investigating anomalies, which is a cornerstone of effective cybersecurity. This approach is ethically problematic due to its inherent risk of overlooking a critical security event, potentially leading to data breaches or service disruptions. A third incorrect approach is to solely rely on automated alerts without human analysis. While automation is crucial, it should augment, not replace, human judgment. Over-reliance on automated systems can lead to false positives or negatives, especially when dealing with novel or subtle threats. This approach is professionally unsound because it lacks the critical thinking and contextual understanding that experienced security analysts bring to risk assessment. It can lead to either unnecessary panic or a dangerous sense of complacency, both of which are detrimental to organizational security. Professional reasoning. Professionals should adopt a systematic, layered approach to investigating performance anomalies. This begins with establishing a baseline of normal network behavior. When deviations occur, the first step is to gather all available data, including performance metrics, system logs, network traffic data, and any relevant security alerts. The next step is to correlate this data with known security events, threat intelligence, potential attack patterns. If a security correlation is found, initiate the incident response plan. If no immediate security correlation is apparent, further investigation into potential non-security related causes, e.g., configuration errors, software bugs, hardware issues, should be conducted, but with a continued awareness of potential security implications. This process ensures that security is considered throughout the investigation, not as an afterthought. Question 15. The monitoring system demonstrates a pattern of unusual outbound network traffic originating from a user workstation that deviates significantly from its typical communication profile, raising concerns about potential data exfiltration or unauthorized access to external resources. Option A. Assume the anomaly is a false positive due to a recent software update and continue monitoring without further investigation. Option B. Immediately block all outbound network traffic from the user workstation to prevent any further potential data exfiltration and initiate a disciplinary review for the user. Option C. Conduct a detailed forensic analysis of the user workstation and network logs to identify the specific applications and processes responsible for the anomalous traffic, correlating findings with known indicators of compromise and Cisco ISE policy violations to determine the actual risk level before initiating any remediation actions. Option D. Implement a blanket network access control policy change that restricts all outbound traffic for all users to a predefined list of approved destinations. The correct answer is C. Conduct a detailed forensic analysis of the user workstation and network logs to identify the specific applications and processes responsible for the anomalous traffic, correlating findings with known indicators of compromise and Cisco ISE policy violations to determine the actual risk level before initiating any remediation actions. Explanation. Scenario analysis. This scenario presents a professional challenge because the monitoring system has detected anomalous activity that could indicate a security breach or policy violation. The challenge lies in accurately assessing the risk posed by this activity without causing undue disruption to legitimate operations or compromising sensitive data. A hasty or incorrect response could lead to significant financial penalties, reputational damage, and a loss of trust from users and stakeholders. The need for a nuanced understanding of the detected behavior, its potential impact, and the relevant regulatory landscape is paramount. Correct approach analysis. The correct approach involves a systematic and evidence-based risk assessment. This aligns with best professional practices and regulatory expectations for data security and privacy. By correlating the anomalous activity with known threat intelligence and established security policies, an organization can accurately determine the severity of the risk. This methodical process ensures that resources are allocated effectively to address genuine threats while minimizing false positives. It also provides a defensible audit trail, crucial for demonstrating compliance with regulations that mandate proactive security measures and incident response. The focus on understanding the context and potential impact of the anomaly before taking action is a hallmark of responsible security management. Incorrect approaches analysis. One incorrect approach is to immediately escalate the anomaly to a full-scale incident response without further investigation. This can lead to wasted resources, alert fatigue among security personnel, and potential disruption to business operations if the anomaly turns out to be benign. Ethically and regulatorily, this approach fails to demonstrate due diligence in assessing the actual risk, potentially violating principles of proportionality and efficiency expected in security operations. Another incorrect approach is to ignore the anomaly, assuming it is a false positive or insignificant. This is a critical failure in risk management. Regulations often require organizations to have robust monitoring and detection capabilities and to act upon detected threats. Ignoring such alerts demonstrates a lack of commitment to security, potentially leading to severe breaches that could have been mitigated. This failure can result in significant legal and financial repercussions, as well as a breach of trust. A third incorrect approach is to implement overly broad and restrictive security policies in response to a single anomaly, without understanding its root cause or scope. This can cripple legitimate user access and business processes, creating a negative user experience and hindering productivity. From a regulatory perspective, such a response might be seen as disproportionate and not based on a proper risk assessment, potentially violating principles of least privilege and operational necessity. Professional reasoning. Professionals should approach such situations by first gathering all available data related to the anomaly. This includes logs from the monitoring system, network traffic data, and user activity logs. The next step is to contextualize this data by comparing it against established baseline behaviors and known security threats. This involves leveraging threat intelligence feeds and internal security policies. Based on this analysis, a risk score or impact assessment should be performed. This assessment should consider the potential impact on confidentiality, integrity, and availability of data, as well as the potential for regulatory noncompliance. Only after a thorough risk assessment should appropriate mitigation or response actions be determined and implemented. This iterative process of detection, analysis, and response ensures that security measures are effective, efficient, and compliant. Question 16. The risk matrix shows a high likelihood and high impact for unauthorized access to sensitive financial data. Given this, which approach to configuring Cisco Identity Services Engine ISE policies would best mitigate this specific risk? Option A. Implement dynamic access policies that grant or deny access based on user identity, device posture, location, and time of access, with stricter controls applied when risk factors are elevated. Option B. Configure static access control lists, ACL, on network devices to permit access to financial data only from specific IP addresses. Option C. Apply a broad policy that restricts all access to sensitive financial data for all users during non-business hours. Option D. Create a user awareness training program focused on data security best practices for accessing financial information. The correct answer is A. Implement dynamic access policies that grant or deny access based on user identity, device posture, location, and time of access, with stricter controls applied when risk factors are elevated. Explanation. Scenario analysis. This scenario presents a common challenge in network security, balancing the need for robust security controls with the operational realities of user access and business continuity. The risk matrix, a fundamental tool in risk assessment, highlights potential threats and their impact. The challenge lies in translating these identified risks into actionable security policies within the Cisco Identity Services Engine (ISE) framework, specifically concerning the implementation of a risk-based access control strategy. Professional difficulty arises from the need to accurately assess the likelihood and impact of a specific threat, unauthorized access to sensitive data, and then map that assessment to appropriate ISE policies, ensuring that the chosen mitigation strategy is both effective and proportionate, without unduly hindering legitimate user operations. This requires a deep understanding of ISE's capabilities and the organization's risk tolerance. Correct approach analysis. The correct approach involves a granular analysis of the identified risk and its direct correlation to user behavior and device posture. By focusing on the specific threat of unauthorized access to sensitive data, the most effective mitigation within ISE is to implement dynamic access policies that adapt based on real-time risk factors. This means leveraging ISE's ability to assess user identity, device health, posture assessment, location, and time of access to determine the appropriate level of access. For instance, if a user attempts to access sensitive data from an unmanaged device or a location outside of normal business hours, ISE can dynamically restrict their access or require additional authentication. This approach aligns with the principle of least privilege and defense in depth, ensuring that access is granted only to authorized individuals on trusted devices, thereby directly addressing the identified risk. This is best professional practice as it is proactive, adaptive, and directly tied to the risk assessment, minimizing the attack surface for unauthorized data access. Incorrect approach is analysis. Implementing a blanket policy that restricts all access to sensitive data for all users, regardless of their context or device posture, is an incorrect approach. This fails to differentiate between legitimate and malicious access attempts, leading to operational inefficiencies and user frustration. Ethically and regulatorily, this could be seen as an overreach of security controls that hinders legitimate business functions without a clear, risk-based justification. Another incorrect approach would be to solely rely on static access control lists, ACL, without considering dynamic factors. While ACLs provide a baseline of security, they are not adaptive to evolving threats or changing user contexts. This approach neglects the risk of compromised credentials or the use of non-compliant devices, leaving sensitive data vulnerable to unauthorized access. This fails to meet the professional standard of implementing comprehensive and adaptive security measures. Finally, ignoring the risk assessment entirely and implementing access policies based on convenience or historical practices is a significant regulatory and ethical failure. This approach is not grounded in risk management principles and leaves the organization exposed to potential data breaches, noncompliance with data protection regulations, e.g., GDPR, CCPA, depending on the exam's implied jurisdiction, and reputational damage. It demonstrates a lack of due diligence in protecting sensitive information. Professional reasoning. Professionals should approach risk assessment and policy implementation by first thoroughly understanding the organization's threat landscape and risk tolerance. This involves using tools like the risk matrix to identify and prioritize potential threats. The next step is to translate these risks into specific, measurable, achievable, relevant, and time-bound, SMART security objectives. When configuring ISE, the decision-making process should prioritize dynamic and context-aware policies that directly mitigate the identified risks. This involves leveraging ISE's advanced features, such as posture assessment, profiling, and conditional access, to enforce granular controls. Professionals must continuously review and update policies based on new threats, changes in the environment, and the effectiveness of existing controls, ensuring that security measures remain relevant and effective. Question 17. Compliance review shows that the recent implementation of Cisco Identity Services Engine, ISE, was not explicitly included in the organization's last comprehensive risk assessment, which was completed prior to the ISE deployment. What is the most appropriate next step to ensure ongoing compliance and security posture? Option A. Rely on the vendor's documentation and default security setting to confirm the security of the Cisco ISE deployment. Option B. Implement a broad, organization-wide security policy update that addresses general network access controls without specific focus on ISE. Option C. Conduct a targeted risk assessment specifically for the Cisco ISE implementation and its integration into the existing network infrastructure. Option D. Update the existing risk assessment document to retroactively include Cisco ISE, assuming no new risks were introduced. The correct answer is C. Conduct a targeted risk assessment specifically for the Cisco ISE implementation and its integration into the existing network infrastructure. Explanation. Scenario analysis. This scenario presents a common challenge in network security where the implementation of a new security solution, Cisco ISE, introduces potential risks that were not fully anticipated during the initial risk assessment phase. The challenge lies in balancing the need for robust security controls with the operational impact and the potential for unintended consequences. A failure to adequately reassess risks after significant system changes can lead to security gaps, compliance violations, and operational disruptions. The professional challenge is to identify and mitigate these newly introduced risks effectively and efficiently. Correct approach analysis. The correct approach involves conducting a targeted risk assessment specifically for the Cisco ISE implementation. This is best professional practice because it directly addresses the identified gap. Regulatory frameworks, such as those underpinning the 300-715 SISE exam, emphasize a proactive and iterative approach to risk management. A dedicated assessment ensures that the unique security posture, configuration, and operational integration of ISE are thoroughly evaluated. This allows for the identification of specific vulnerabilities, misconfigurations, or policy gaps introduced by ISE, and the development of appropriate mitigation strategies. This aligns with the principle of continuous monitoring and improvement mandated by many security standards, ensuring that security controls remain effective as the network environment evolves. Incorrect approaches analysis. Relying solely on the existing pre-ISE risk assessment is professionally unacceptable because it fails to account for the significant changes introduced by the new system. This represents a regulatory failure to maintain an up-to-date risk profile, potentially violating compliance requirements that mandate regular risk reviews. It also creates an ethical failure by exposing the organization to known or discoverable risks without mitigation. Assuming the vendor's default security configurations are sufficient is also professionally unacceptable. While vendors strive for secure defaults, they cannot account for an organization's specific threat landscape, compliance obligations, or unique network architecture. This approach demonstrates a lack of due diligence and a failure to tailor security controls to the organization's specific risk appetite and requirements, leading to potential compliance and security breaches. Implementing a broad, generic security policy without specific consideration for ISE's capabilities and integration points is professionally inadequate. While a general security policy is necessary, it may not adequately address the nuanced risks associated with a sophisticated identity and access control solution like ISE. This can lead to misconfigurations, ineffective policy enforcement, and the creation of new attack vectors, representing a failure to implement controls commensurate with the risks introduced by the technology. Professional reasoning. Professionals should adopt a structured, iterative risk management framework. When significant changes occur, such as the deployment of a new security platform like Cisco ISE, a formal risk reassessment process should be initiated. This process should involve identifying new threats and vulnerabilities, analyzing their potential impact, and determining appropriate mitigation strategies. The decision-making process should prioritize actions that directly address identified risks, align with regulatory requirements, and support the organization's security objectives. This involves understanding the specific functionalities of the technology being implemented and how they interact with the existing security posture. Question 18. The efficiency study reveals that the current process for implementing network changes, which includes configuring Cisco Identity Services Engine (ISE) policies, is experiencing delays due to the time allocated for risk assessment. To expedite deployments, a proposal suggests streamlining the risk assessment process by conducting it only after a change has been fully implemented and verified for functionality, which approach best aligns with professional cybersecurity practices and regulatory expectations for risk management. Option A. Rely exclusively on automated risk assessment tools without any human review to speed up the process. Option B. Delegate the risk assessment responsibility to the IT operations team, as they are most familiar with the network infrastructure and operational needs. Option C. Conduct a comprehensive risk assessment solely after the network change has been successfully implemented and verified for operational functionality. Option D. Integrate risk assessment into the change management workflow, ensuring it is completed and reviewed before any network changes, including ISE policy updates, are deployed. The correct answer is D. Integrate risk assessment into the change management workflow, ensuring it is completed and reviewed before any network changes, including ISE policy updates, are deployed. Explanation. Scenario analysis. This scenario presents a common challenge in network security, balancing the need for robust security controls with the operational demands of a dynamic environment. The efficiency study highlights a potential conflict between the thoroughness of a risk assessment and the speed required for network changes. The professional challenge lies in ensuring that risk assessments are not merely a procedural checkbox, but a meaningful process that genuinely informs security decisions, especially when faced with pressure to expedite deployments. The core difficulty is maintaining the integrity and effectiveness of the risk assessment process without unduly hindering legitimate business operations. Correct approach analysis. The correct approach involves integrating risk assessment into the change management lifecycle, ensuring that security implications are evaluated before implementation. This aligns with best practices for proactive security and regulatory compliance. Cisco Identity Services Engine (ISE) is a critical component for enforcing security policies based on identity and context. A risk assessment that informs ISE policy configuration ensures that the security posture is aligned with identified threats and vulnerabilities. This approach demonstrates due diligence, a key ethical and often regulatory expectation in cybersecurity. It ensures that security is a foundational element of network changes, not an afterthought, thereby minimizing the likelihood of introducing new vulnerabilities or misconfigurations that could be exploited. This proactive stance is crucial for maintaining a secure and compliant network infrastructure. Incorrect approaches analysis. One incorrect approach is to conduct risk assessments only after a change has been implemented. This is a reactive and fundamentally flawed security strategy. It represents a significant regulatory and ethical failure because it bypasses the opportunity to prevent security risks before they materialize. If a vulnerability is introduced, the organization is exposed to potential breaches, data loss, and non-compliance with data protection regulations. This approach demonstrates a lack of foresight and a failure to uphold the duty of care expected of security professionals. Another incorrect approach is to rely solely on automated tools without human oversight for risk assessment. While automation is valuable for efficiency, it can miss nuanced risks or context-specific vulnerabilities that a human analyst would identify. This can lead to an incomplete or inaccurate risk profile, potentially resulting in inadequate security controls being implemented in ISE. Ethically, this can be seen as an abdication of responsibility, as the security professional is not applying their expertise to critically evaluate the risks. From a regulatory standpoint, it may not meet the standard of reasonable security measures if critical risks are overlooked due to over-reliance on automation. A third incorrect approach is to defer risk assessment to the IT operations team without security expertise. This creates a significant conflict of interest and a knowledge gap. IT operations teams are often focused on functionality and uptime, which may not align with security best practices. Without specialized security knowledge, they may not identify or adequately assess security risks, leading to the implementation of insecure configurations. This is a clear ethical and regulatory failure, as it places the responsibility for security in the hands of individuals not qualified to perform it, potentially exposing the organization to significant harm and non-compliance. Professional reasoning. Professionals should adopt a risk-based approach to security, where decisions are informed by a thorough understanding of potential threats and vulnerabilities. This involves integrating security considerations into all stages of the IT lifecycle, including planning, design, implementation, and operation. When faced with pressure to expedite changes, professionals must advocate for the necessary time to conduct proper risk assessments, explaining the potential consequences of bypassing these crucial steps. This requires strong communication skills, the ability to articulate risk in business terms, and a commitment to upholding professional ethics and regulatory requirements. The decision-making process should prioritize the protection of organizational assets and data, ensuring that security controls, such as those configured in Cisco ISE, are robust and effectively mitigate identified risks. Question 19. Compliance review shows that a financial services organization is planning to implement Cisco Identity Services Engine ISE to enhance network access control and enforce security policies. The project team has focused heavily on the technical configuration and integration of ISE with existing network infrastructure, but has not yet conducted a formal assessment of the potential risks associated with its deployment and operation. Which of the following approaches best addresses the immediate compliance and security requirements before proceeding with the full implementation? Option A. Proceed with the technical configuration and deployment of Cisco ISE, relying on vendor best practices and default security settings to ensure a secure implementation. Option B. Conduct a comprehensive risk assessment to identify potential threats, vulnerabilities, and their impact on the organization's assets and data, followed by the development of mitigation strategies tailored to the specific ISE deployment. Option C. Prioritize the training of network administrators on Cisco ISE features and functionalities, assuming that technical proficiency will inherently mitigate most security risks. Option D. Delay the implementation of Cisco ISE until a complete overhaul of the organization's entire network security architecture is completed to avoid potential integration conflicts. The correct answer is B. Conduct a comprehensive risk assessment to identify potential threats, vulnerabilities, and their impact on the organization's assets and data, followed by the development of mitigation strategies tailored to the specific ISE deployment. Explanation. Scenario analysis. This scenario presents a common challenge in network security where the implementation of a new technology, Cisco ISE, introduces potential risks that must be proactively identified and mitigated. The professional challenge lies in balancing the benefits of enhanced network access control and security posture management offered by ISE with the inherent risks associated with its deployment, configuration, and ongoing operation. A failure to conduct a thorough risk assessment can lead to security vulnerabilities, compliance violations, and operational disruptions. The complexity arises from the interconnectedness of network infrastructure, user identities, and security policies, requiring a holistic view. Correct approach analysis. The correct approach involves a systematic and comprehensive risk assessment process. This begins with identifying all potential threats and vulnerabilities associated with Cisco ISE, such as misconfigurations, unauthorized access attempts, data breaches, and denial of service attacks. It then involves analyzing the likelihood and impact of these risks. Based on this analysis, appropriate mitigation strategies are developed and implemented. This aligns with best practices in cybersecurity and regulatory frameworks that mandate proactive risk management. For example, in the U.S., NIST Cybersecurity Framework, CSF, principles emphasize identifying, protecting, detecting, responding, and recovering, all of which are informed by a robust risk assessment. Similarly, ISO 27001, a widely adopted international standard for information security management, places a strong emphasis on risk assessment as a foundational element of an information security management system. This approach ensures that security controls are proportionate to the identified risks and that resources are allocated effectively to address the most critical threats. Incorrect approach is analysis. Implementing Cisco ISE without a prior risk assessment is a significant regulatory and ethical failure. It demonstrates a disregard for due diligence and a reactive rather than proactive security posture. This approach violates the principle of security by design and can lead to non-compliance with regulations that require organizations to protect sensitive data and systems. For instance, in the U.S., the Health Insurance Portability and Accountability Act, HIPAA, mandates risk analysis to identify and address potential risks and vulnerabilities to the confidentiality, integrity, and availability of electronic protected health information. Failing to perform this analysis before deployment could result in severe penalties. Focusing solely on the technical configuration of Cisco ISE and neglecting the broader risk landscape is another failure. While technical expertise is crucial, it is insufficient without understanding the business context, potential attack vectors, and the impact of security incidents. This narrow focus can lead to overlooking critical risks that are not purely technical, such as insider threats or social engineering attacks targeting users with privileged access granted by ISE. Relying on vendor default configurations without a risk assessment is also professionally unacceptable. Vendor defaults are often designed for broad compatibility and may not align with an organization's specific security requirements or risk appetite. This can leave the system vulnerable to known exploits or misconfigurations that are easily discoverable. It bypasses the essential step of tailoring security controls to the unique environment and threat profile of the organization, which is a fundamental requirement for effective risk management. Professional reasoning. Professionals should adopt a structured risk management framework. This involves 1. Scope definition. Clearly define the scope of the risk assessment, including all components of the Cisco ISE deployment and its integration with the network. 2. Threat and vulnerability identification. Brainstorm and document potential threats, e.g., malware, unauthorized access, and vulnerabilities, e.g., weak authentication, unpatched software specific to Cisco ISE and its environment. 3. Risk analysis. Evaluate the likelihood of each threat occurring and the potential impact on the organization, e.g., financial loss, reputational damage, operational disruption. 4. Risk evaluation. Prioritize risks based on their severity. 5. Risk treatment. Develop and implement mitigation strategies, including technical controls, policy changes, and user training. 6. Monitoring and review. Continuously monitor the effectiveness of controls and periodically review and update the risk assessment as the environment and threat landscape evolve. This systematic process ensures that security decisions are informed, defensible, and aligned with organizational objectives and regulatory obligations. Question 20. Strategic planning requires a comprehensive approach to implementing Cisco Identity Services Engine ISE policies to ensure robust security and operational efficiency. Considering the potential for both security gaps and user disruption, which of the following implementation strategies best aligns with professional best practices for deploying ISE? Option A. Deploy an immediate default deny posture for all network access, requiring explicit authorization for every connection attempt, without prior analysis of legitimate access needs. Option B. Rely exclusively on MAC address authentication for all network access to simplify policy management and reduce the complexity of user and device profiling. Option C. Configure broad, allow all policies across the network during the initial deployment phase to avoid any immediate access issues, with policy refinement planned for a later date. Option D. Implement a phased approach, beginning with critical assets and sensitive data, and progressively expanding policies based on risk assessment and operational feedback. The correct answer is D. Implement a phased approach, beginning with critical assets and sensitive data, and progressively expanding policies based on risk assessment and operational feedback. Explanation. The scenario presents a common challenge in network security, balancing the need for granular access control with the operational overhead of managing complex policies. The Cisco Identity Services Engine ISE is designed to address this by enabling policy enforcement based on user identity, device posture, and location. The professional challenge lies in designing an ISE policy that is both effective in mitigating security risks and sustainable from an administrative perspective, avoiding overly broad or overly restrictive configurations that could lead to security gaps or user disruption. Careful judgment is required to align technical capabilities with business requirements and regulatory compliance. The correct approach represents best professional practice because it prioritizes a phased, risk-based implementation of ISE policies. This aligns with the principle of least privilege, ensuring that access is granted only to the resources necessary for a user or device to perform its function. By starting with critical assets and sensitive data, and then expanding to less critical areas, the organization can effectively demonstrate the value of ISC, refine its policies based on real-world usage, and minimize the risk of unintended consequences. This methodical approach also facilitates better training and adoption by IT staff and end users. Furthermore, this strategy supports compliance with general data protection and security best practices, which often mandate a risk-aware approach to access control and data handling. An incorrect approach that focuses solely on a default deny posture without a clear understanding of legitimate access needs is professionally unacceptable. This can lead to significant operational disruption, as legitimate users and devices may be blocked from accessing necessary resources, hindering productivity and potentially creating workarounds that bypass security controls. This approach fails to adequately consider the business context and can be seen as a failure to implement security in a proportionate and effective manner, potentially violating principles of operational efficiency and user enablement. Another incorrect approach that involves implementing overly broad, allow all policies for initial deployment is also professionally unacceptable. This completely undermines the purpose of ISC by failing to enforce any meaningful access controls. It creates significant security vulnerabilities, allowing unauthorized access to sensitive data and systems. This approach demonstrates a lack of understanding of risk management and a failure to implement security controls that are commensurate with the threats faced by the organization. It directly contradicts the fundamental principles of network security and identity management. A third incorrect approach that relies solely on device MAC addresses for authentication, without incorporating user identity or posture assessment, is professionally deficient. While MAC address filtering can provide a basic layer of access control, it is easily spoofed and does not provide assurance about the identity of the user operating the device or the security posture of the device itself. This approach fails to leverage the full capabilities of ISE for robust security and compliance, leaving the network vulnerable to unauthorized access and malware propagation. It represents a missed opportunity to implement a more secure and dynamic access control strategy. The professional decision-making process for similar situations should involve a thorough understanding of the organization's assets, data sensitivity, user roles, and compliance requirements. This should be followed by a risk assessment to identify critical areas for immediate protection. The implementation of ISE policies should be iterative, starting with a pilot group or specific use case, and progressively expanding based on successful outcomes and lessons learned. Continuous monitoring and refinement of policies are essential to maintain an effective security posture.